So welcome. Just a quick um, look at what we're going to do today and how we're going to finish up the week. Um, so we're going to go over the 8.3 today, quadratic functions in standard form and graphing them and looking at that and finding the key pieces. Um, excuse me. I will kind of walk you through the Schoology page, although most of you um, have done a fine job of finding where things are, which is great. Um, but a few of you still need to turn in some homework, so we will walk through that at the end of the hour before we, or the end of the class period, before we move into um, breakout rooms. It does say for three um, that you need a graphing calculator. That's not 100% true. A calculator may be helpful. Um, some students like to make their table of values for their graphs, and the calculator would be very good at helping with that. So you don't have to have one. It might be nice if you like that table feature. It can also be nice, and you'll see as we work through problems, to help with just some calculation stuff. And then, we'll end up, you'll have some time to work, and then we'll do our breakout rooms and we'll all be ready to go then for the end of the week. Uh, the end of the week, Wednesday, Thursday, there is a quiz review and a quiz. I would suggest, again, in order to stay on task or on time, make sure that quiz is done by Sunday. Then you don't have to worry about it over spring break. That'll be kind of a nice thing. Don't put it off and say, well, I'll do it tomorrow. I'll do it tomorrow. I'll do it tomorrow. Pretty soon tomorrow comes and is gone, and you're behind, and I don't want that to happen. So we'll take a look at that as well. All right. Questions? So again, this is in the blue packet. If you haven't picked them up, they've actually been moved now to the main office. So if you are picking up packets, they will be available in the main office now, if you decide to pick one up. Again, I would suggest doing it, saves you a little bit of writing time. All right, so for 8.3, we're dealing with quadratic functions in standard form now, rather than vertex form. And we're going to do very much what we did when we had it in vertex form. We're going to find the vertex, we're going to find the axis of symmetry, and we're going to do some graphing. So all sorts of fun stuff. All right, we're going to start with some definitions, some formulas. So when we're in standard form of a quadratic equation is f of x equals ax squared plus bx plus c. With standard form, usually we find the axis of symmetry first. And the way we do that, we take the opposite of whatever our b value is, so the opposite of this value, and divide by 2 times whatever our value for a is. And that'll give us the equation for the vertical line for our axis of symmetry. To find the vertex, then, we take that x value and plug it into our function to get the y value, or the f of x value. Again, f of x and y in our equation mean the same thing. And then the y-intercept is always going to be whatever C is, 0C for the y-intercept. So the y-intercept pretty easy to find in standard form, a little bit of work to get the vertex. In vertex form, the vertex is usually a little bit easier to find, and it takes a little bit of work to figure out what the y-intercept is. So there's a give and take, advantages and disadvantages to each form. And we will actually look at, if we start in standard form, how can we write our equation in vertex form? And if we're in vertex form, how can we rewrite in standard form? That'll be kind of how we end class. All right. So for the beginning, all we're going to do is identify the values for A, B, and C, use those to find the axis of symmetry, the vertex, and the y-intercept. So here is our first equation in standard form. The biggest thing to be careful of is the signs for our values A, B, and C. So A is -2, B is +4, and C is -3. So anytime there's subtraction, that means that value is going to be thought of as negative. Once we know A, B, and C, we can find the axis of symmetry. So the axis of symmetry, x equals the opposite of b divided by 2a, just using that formula. So we get the opposite of 4 over 2 times -2, which is -4 over -4, which is +1. For the vertex, 1 is going to be the x-coordinate of the vertex. Again, that axis of symmetry and x-coordinate for our vertex are the same. And to find the y value, I take 1 and plug it in for x. So let's see, 1 squared is 1 times -2 is -2. 4 times 1 is 4. And then we have that -3. And if we simplify that, -2 plus 4 is 2. 2 minus 3 is -1. There's our vertex. Last thing we want is the y-intercept. And if we know what C is, the y-intercept is pretty straightforward. It's whatever our value is for C with 0 as our x-coordinate. So 0, -3 for our y-intercept. Questions on that one? All right, go to the next example. So this one's for you to try. I'll give you just a couple of minutes, and then we'll take a look at answers. So we have the standard form equation, x squared minus 6x plus 5. Find the axis of symmetry, find the vertex, and find the y-intercept. If you have questions, feel free to put them in the chat, and I will answer them as I get them. All right. So for this one, our axis of symmetry, I should write these down. A equals 1, B equals -6, C equals 5. Always a good idea to write those down. So I get the opposite of B over 2 times A, which would be 6 over 3. I'm sorry, 6 over 2, getting a step ahead of myself, which is 3 for our axis of symmetry. So our vertex has 3 for an x coordinate. I'm going to plug in over here to get the y coordinate. So we get 3 squared minus 6 times 3 plus 5. Be careful with the parentheses and the squaring. If you have a negative value, it should be in parentheses. If you have a negative in front of the x squared, that would not go in the parentheses. And again, we'll take a look at some examples as we work through some more problems. 3 squared is 9. Minus 6 times 3 is 18 plus 5. 9 minus 18 is -9 plus 5 is -4. And our y-intercept is 0, and whatever c is, in this case, c is 5. So now all we're going to do, we're going to add the graphing component. So now we want to find the vertex, the axis of symmetry, the y-intercept, and then use those to graph the following function. Now, generally when we graph, we want at least 2 points on each side of the axis of symmetry, which in the 8-2 homework, some of you did very well with. Others, when you had to do the graphs, just did 1 point on each side for a total of 2 points. So we should have a total of at least 5 points when we graph the vertex, and then 2 points on each side of the axis of symmetry. And so I will do my best to model that as we go through these examples. So again, I am going to write down A is -1, B is +4, C is -2. And I'm going to start with the axis of symmetry. To me, it's just easier. Axis of symmetry is the opposite of B over 2 times A. So x equals 2 is my axis of symmetry. My vertex is going to be at 2 something. Now to figure out that something, I'm going to plug 2 in for x. So here I have the negative, and then I take x squared. So I want to be careful that I square the 2 first and then apply that negative sign. So it's 2 squared, which is 4, then take its opposite. 4 times 2 is 8. And then we have that -2. -4 plus 8 is +4, -2 is +2. My y-intercept is 0, C. In this case, C is -2. So we're going to have that point. And because of the symmetry, we would have that same y value on the opposite side of the axis of symmetry. So it's 2 away from the axis of symmetry on the left. So we go 2 away on the right. Again, I like to have at least one more value. And so one of the things you could do is you could put that equation into your calculator, into the y equals screen if you have a graphing calculator, and look at a table. You could also just pick a value. Like you could say, well, I'm going to use 1, plug 1 in for x, see what you get for y, and then use the symmetry that way as well. Or if you remember the pattern, right? So it's usually over 1, up 1, over 1, up 3, but we have to multiply that up value by a. So instead of over 1, up 1, I go over 1, down 1. And over 1, down 3 puts me right at that y-intercept, so that I know that fits that pattern. It's a good way to reinforce that. And if we wanted to, we could do another point, over 1, down 5. You don't have to do 3, but I will say the more points you do, the more accurate your graph is. Right? The last thing, I could write now my equation in vertex form if I wanted to. So to convert from standard form to vertex form, all you do, remember, vertex form is a x minus h squared plus k. In this case, a is -1. So that a that we have here is the same a we have here. And then our vertex, remember, is hk. So in this case, in vertex form, so that's vertex form. And so I'm going to actually write, even though it doesn't say to on any of these problems, I'm going to convert to vertex form each time as well, just to show the vertex form of the equation. All right. Next example. A equals 2, B equals 4, C equals 3. Again, I'm going to start with my axis of symmetry, the opposite of B over 2A. There's the formula, and then I can fill in. B is 4, A is 2. In my denominator, I get 2 times 2, which is 4. -4 divided by 4 is -1. So -1 is also the x-coordinate of my vertex. I draw my axis of symmetry. Excuse me. Plugging in -1 for my x. So again, here the x value is negative, so the whole thing goes in the parentheses. So we have -1 squared, which is 1 times 2. 4 times -1 is -4 plus 3. Um, 2 minus 4 is -2, plus 3 is +1. So -1, +1, that's my vertex. My y-intercept is 0, and the value for C, which is 3. That's 1 away from my axis of symmetry on the right, so I will also have a y value of 3, 1 away on the left. my pattern over 1 up, in this case 2, because A is 2. So then I'd go over 1 up 3 times 2, or 6. Okay, it's not 6 is not the value I go to, but I go up 6 places. So 1, 2, 3, 4, 5, 6. And then I can't graph any more points. I don't have room on my grid at this point. So there's my parabola from standard form. Again, if I wanted it in vertex form, A is 2, H is -1, so minus -1 is the same as plus +1, and K is +1. So that would be the vertex form of my equation. I know it didn't ask for it, but it's always good to be able to recognize and convert from one form to the other. Example C. Again, here A is 1, B is 2, C is 4. I'm going to start with my axis of symmetry. On your homework, you really don't need to write the formula for the axis of symmetry. You could go right into the opposite of 2, and then, oops, and 2 times A. I just like to reinforce that formula. So -1 is my axis of symmetry. Just like it was on the last one. Yeah. My vertex then, if I plug -1 in for X, -1 squared is 1. 2 times -1 is -2. And then we have +4. 1 minus 2 is -1. -1 plus 4 is +3. So there's my vertex. My y-intercept, 0, and then whatever C is, in this case, C is 4. Because I have a y value of 4, when I'm 1 unit to the right of my axis of symmetry, I'll have y equals 4, 1 unit to the left of my axis of symmetry as well. And we can see A is 1, so we have that over 1, up 1 pattern, then over 1, up 3. And if I had room, I could go over 1, up 5. Now, on your homework, you actually don't need to draw in the parabola. Some of you did on 8.2 and did a fine job with it. As long as you plot the points and just put where the points are, you don't need to draw in the parabola, but you should draw in that axis of symmetry. Then vertex form. A was 1, so I don't need to write it. X minus my x coordinate, so minus -1 is the same as +1, plus my y coordinate. And there's vertex form. All right. Any questions on that so far? So here's an opportunity for you to try it. Again, I'll give you a few minutes. go ahead and try this problem, and we will come together in 2 minutes and take a look at answers. All right. So starting again, I always start with the axis of symmetry. It just, to me, makes sense. So my axis of symmetry, oh, actually, I start with A, B, C. So I get the opposite of B over 2A for my vertex, or sorry, my axis of symmetry. So -4 over 2 times -2, which is -4 over -4, or +1. Vertex is 1. So the Y value then, I plug 1 in for X. Again, being very careful, using those order of operations from middle school. I square the 1 first. That gives me 1 times -2 plus 4 times 1 minus 3. -2 plus 4 is +2. +2 minus 3 is -1. So my axis of symmetry, my vertex over 1 down 1, and then the y-intercept, which I saw some in the chat had this written in, and they were exactly right. 0, -3. And again, that's 1 unit to the left of my axis of symmetry. So I have the same corresponding point 1 unit to the right. So 2, -3 is on my parabola. And then I can, again, use either a table of values, plug another value in for X, or use the pattern. So it was over 1, down 2, over 1, down 6. 1, 2, 3, 4, 5, 6 would be where that next point would be. And then if I had room, I could go over 1, down 10. I just don't have enough room on my graph for that. And there's my parabola. Again, in vertex form, -2 is my value for A, x minus h squared plus k. K is negative in this case. So we subtract. All right. Anyone with questions there? Okay. So we've done a lot of work in standard form. Now it's time to go from vertex form to standard form. So the process is pretty straightforward, I think, but we're going to have to use some of those multiplying binomial rules and methods that we learned last trimester. So we need to take x minus 4 and square it, which means x minus 4 times x minus 4. You could use FOIL, you could use box, you could say, hey, that's a special case, and I remember the pattern. All of those will work. I'm going to use the box method for this one. I'll actually use all 3 of those methods as we look at excuse me, the patterns here. X times x is x squared. X times -4 is minus 4x. -4 times x is -4x. -4 times -4 is plus 16. Combine my like terms, negative 4x minus 4x is negative 8x. So in my parentheses, when I multiply that out, I actually don't need to use the parentheses anymore. I would get x squared minus 8x plus 16. And then I also have to have that plus 5. So the last step will always be combining like terms if we have them. So I do have some like terms. X squared minus 8x plus 21. Okay, and that's in standard form. Good thing we didn't have to graph that one, because plus 21 for a y-intercept would be way up off of our graph. So, but that is going from vertex form to standard form. If you don't like the box method, if you prefer the FOIL method, you can certainly use that. I'll show that with this example. I'm actually going to go over here and write x plus 2 squared is x plus 2 times x plus 2. Using the FOIL method, I multiply the first terms. X times x is x squared. Then I multiply the outside or outer terms. That would give me 2x. The inner terms would give me 2x. And the last term in each binomial is 2 times 2, which is 4. The next thing I would do is, again, combine my like terms. I like combining like terms before I do anything else. So 2x and 2x is 4x. Excuse me. Now, because I have a value a in front, I need to distribute the 3. So 3x squared plus 12x plus 12 minus 6. And the last piece here, take the 12 minus 6. And 12 minus 6 is positive 6. All right, so here's one for you to try. Again, I'll give you a couple of minutes, but I want you to take 4 times the quantity x minus 7 squared minus 3, write it in standard form. All right, so for this one, I'm going to use the special formula, which says when we have a binomial squared, we can square the first term, multiply the two terms together, so negative 7 times x is negative 7x, and then double it, and square the last term. Negative 7 squared is positive 49. Distribute the 4. By the way, if you didn't remember that special case, don't worry. I hadn't had that memorized when I was in high school. I don't think I memorized that until I worked more and more with quadratics. 4 times 49 is 196. And then we're going to subtract 3. So another one, probably a good thing we're not graphing it, that y-intercept of 193 would be kind of tough to get to. last example that we're going to look at, we have the trajectory of water fountain A is represented by a function in standard form. That function is f of x equals negative x squared plus 2x plus 8. And the trajectory of fountain B is represented with a table of values. And we have that table of values given to us. Compare the vertex of each function. Which fountain reaches a greater height? Okay. So we're going to find the vertex of fountain A. To do that, we're going to first find the axis of symmetry. So the x coordinate of the vertex is the opposite of B over 2A. A is -1, B is 2, C is 8. It's -2 over -2, or +1. The y value then is the opposite of 1 squared plus 2 times 1 plus 8. Again, being very careful with the way we do our order of operations, we square the 1 first. 1 squared is 1, then we take the opposite. 2 times 1 is 2. So we have 1, -1 plus 2 is +1, plus 8 is 9. Our vertex is 1, 9, which means our maximum height is 9. So remember the vertex, because this parabola opens down, the vertex is the maximum in both cases. So for B, we need to figure out the vertex. And the nice thing is, we have this symmetry in B. So that means the thing in the middle has to be our vertex. And again, the y value of our vertex in this case is the maximum. So our conclusion, I hope, is fountain B reaches, I want to make sure I have this the wording correctly. Which fountain reaches a greater height? Yes, reaches a greater height. All right. So last thing I want to look at before we break into our breakout rooms is I want to look at the Schoology page real quick. All right, so second hour right there. Again, most of you already know, if I click on the chapter 8, and it looks like I need to put in this week's schedule, sorry about that. Chapter 8, and then each lesson that we've done in chapter 8 is there. And then when you open the lesson, there is a video that one of the other teachers has done. There will also be our Zoom recording, and then a copy of the notes in case you missed something, a note check, and a homework for each lesson. I do set it up so you have to do the note check first. So if you don't do the note check, you can't get to the homework, is the way that that should work. It doesn't always work that way, but that's the way it should work. Then further down, you'll see this quiz review and quiz. I will open that up today, so it will be available. Just a reminder, there is the review. And then videos that go through the solutions. For some reason, I'll have to do a little editing. These videos are linked directly in the questions. That should be 8.1 to 8.3. I think it was a copy and paste mistake on my part. So do the review, and then there will be the quiz. So click on that next folder, and usually the quiz is inside a folder inside of that folder. So just you'll probably have to go into two different folders to get to the quiz. But that will be open and available today, later today. So again, my suggestion, do all the homework first, then do the review, then go ahead and take care of the quiz. Questions?